All right, next in our series of joyful exploration of graphing linear equations, we'll take a look at graphing an equation in two variables, but we are going to derive our own ordered pairs. And the way we're going to derive our own ordered pairs is we'll start out, because we're organized people, right? That's important. If we're going to be mathematicians, we've got to be organized and probably a little geometric. So down here, I'm going to draw with my straight line capabilities, freehanding, a little box, and I'm going to divide it up along these lines here. This is looking more and more like a shopping bag or something. However, no problem. And what we'll do at the top is we're going to throw in an X here to show us which of the X values we're working with, and a Y to show which of the Y values we're working with. And what we're going to do with this little table is we are going to create ordered pairs in each of these three horizontal rows from our original equation up here. And we make completely random and arbitrary choices of the numbers that we're going to work with and the variable that we start with. I'm sort of habitual. I'm just going to start with X in this case, and I like to start with a small number for X. It makes calculations easier and decreases my chances of making error. So I'm going to say when X is equal to 2, what's Y equal to? And the way to work this out is I'm going to take my X equals 2 up here, and I'm going to substitute the 2 value in for X in the equation and see what we get for Y. So 3x now becomes 3 times X now becomes 3 times 2 because we're using 2 for X plus Y equals 5. So here we go. We're doing some algebra with an equation. This is going to turn into 3 times 2 is 6 plus Y equals 5. We use the addition principle by subtracting 6 from both sides here, so we get down to simply Y equals, and we end up with Y equals 5 minus 6 is minus 1. So I will throw minus 1 in. So my first ordered pair that I'm going to plot or work with is going to be 2 and minus 1. Nicely tucked away in their parentheses there, because that's the way it goes. So we'll throw in a 1 for X. Let's see what happens when X is equal to 1. So let's take some space up here. 3 times when the X value is 1 plus Y equals 5. 3 times 1 is 3 plus Y equals 5. Going to subtract 3 from both sides. Y is equal to 5 minus 3, or 2. There is my Y value for my second ordered pair, which will become 1, 2. Okay, I feel confident. I think I'm doing well here. Let's just see what happens when we throw a negative value in for X. We can do whatever we want. So back to the formula, we're substituting negative 1 in now for the X value. 3 times negative 1 plus Y equals 5. 3 times negative 1 is negative 3 plus Y equals 5. I'm going to add 3 to both sides to isolate the Y. And I get Y is equal to 5 plus 3 is 8. Okay. So what I like about this, as I scribe out my third ordered pair here, is that they all fit within my plane. It doesn't really do me any good to work out ordered pairs that look like 27 and minus 36 when my plane just runs out to 10 either way, plus 10 or minus 10. So I don't want big numbers, and that's why when I'm starting to choose arbitrarily here, I choose some little ones. So I'm trying to stay fairly close to the origin, within the plane anyway. Okay, so first I will go and plot the first of my numbers here, if I can find my, if I can find my stylus here. So the first number I'm going to plot is going to be positive 2 in the X direction, which will occur right about here, and down to negative 1 in the Y direction. So that locates me a point right about here, this intersection here. And my second point is positive 1 in the X direction, which about here, and up to positive 2 in the Y direction, leaves us a point there. And if I have minus 1 in the Y direction, I go all the way up to positive, or y, pardon me, minus 1 in the x direction, I go all the way up to positive 8 in the y direction. I have 3 points here, kind of roughly plotted out because my accuracy isn't great with the tablet again, but you get the idea. In theory, they form a straight line because linear equations always form a straight line, and I draw the straight line through the 3 points, put an arrowhead on either end to indicate that we're going off into eternity, and I have graphed the solution set for our original equation, 3x plus y equals 5, as this red line over here going through these 3 points. Now, as you can probably see, I only require 2 points ever to draw a straight line. It's not a bad idea to include a third or a fourth in there just to make sure I haven't made some simple error somewhere along the line with one of my first 2 points. The third point kind of serves as a check to make sure that I'm in the right area. If I was graphing this equation and ended up with a point over in this area here, then I would know something was up because it needs to be a straight line. And so this is a good check for that. In any event, there we go. Graphing 2 variables as we generate ordered pairs from the original equation. Nothing to that.